Imagine the unthinkable, a massive rock from space hurtling toward Earth, carrying with it the destructive power of 1,000 nuclear bombs. A 350-meter-wide asteroid named Apus is currently on a path that brings it extremely close to Earth, and it could make several close passes in the future, with some astronomers worried about the possibility of a catastrophic collision. This scenario sounds like something out of a science fiction disaster movie, but it's all too real. The implications of a potential asteroid impact are terrifying, and yet, we may only be beginning to understand the true risk that space rocks like Apus pose to our planet. In 2004, astronomers at the Pinnacle National Observatory, led by Roy Extern, David Thalin, and Fabrizio Bernardi, made a breakthrough discovery. They identified an S-type asteroid, which they later named Apus. This particular space rock is composed mostly of silicate rock with a mixture of iron and nickel. The sheer size of Apus, about the height of the Empire State Building, caught the attention of astronomers worldwide. It wasn't just its size that was alarming, but its orbit. This asteroid is not a distant object drifting harmlessly through space. Its orbit brings it dangerously close to Earth. The object will pass close to our planet in 2029, and in subsequent years, it will make a series of even closer approaches. While the asteroid is not expected to hit Earth in the next few decades, scientists have been keeping a close eye on it, considering the potential risks and preparing for all possible scenarios. The most immediate concern with Apus is the energy it would release if it were to impact Earth. The asteroid is large enough that its collision would release an estimated 900 megatons of TNT, far greater than the largest nuclear bomb ever detonated by humanity, the Tsar Bomba, which had a yield of 50 megatons. The power of such an impact would be devastating, causing catastrophic destruction at the site of the impact and creating shockwaves that would devastate large areas surrounding the collision zone. If Apus were to hit the ocean, it could trigger enormous tsunamis that would sweep across coastal regions, causing unimaginable devastation to major cities and populations living by the water. But while the consequences of an Apus impact would be catastrophic, the likelihood of a collision in the near future is not as high as it might seem. In fact, when Apus was first discovered, scientists estimated that the chance of an impact in 2029 was about 1 in 37, or roughly 2.7%. This risk, while concerning, was far from a certainty, and additional observations and research have further lowered the likelihood of an impact. Still, the fact that Apus will come close to Earth multiple times in the coming decades has left many wondering, what would we do if this asteroid did pose a real threat? To answer this question, NASA and other space agencies around the world have been working on developing plans to protect Earth from potential asteroid impacts. The concept of planetary defense has become a priority, especially as we continue to discover more near-Earth objects, NEOs, like Apus. Although there are many unknowns when it comes to asteroid defense, experts agree that the more we learn about these objects, the better prepared we will be to protect our planet. In 2029, Apus will pass within a relatively close distance of Earth, but it will not collide with our planet. At that time, its orbit will bring it about 31,000 kilometers from Earth, which is below the geostationary satellite orbit. This means that Apus will be visible to the naked eye as it streaks across the sky, a spectacular and yet ominous sight for anyone who happens to be looking up. For astronomers, this close encounter presents a unique opportunity to study the asteroid in detail. As the object passes by, scientists plan to observe Apus closely in order to gather valuable data about its composition, orbit, and behavior. This information will be crucial for understanding how Apus and other asteroids interact with the solar system and, perhaps more importantly, how we might prevent a future collision. But even though Apus will pass safely in 2029, the asteroid's repeated close approaches in the years ahead keep scientists on edge. The next few decades will see Apus making additional close passes in 2036 and 2068. In 2036, the asteroid will pass even closer to Earth, just 31,000 kilometers from our planet's surface. For perspective, this is roughly 1/10 the distance from Earth to the Moon. While the asteroid will not hit Earth in 2036, it will be close enough that it could potentially be altered by gravitational forces from Earth or the Sun. In fact, some astronomers initially worried that these close passes could change Apus's trajectory and increase the risk of a collision. However, after recalculating its orbit, NASA has concluded that Apus will not pose a risk of collision in 2036. The asteroid's orbit is stable, and its trajectory will not change enough to bring it on a collision course with Earth. Still, the fact that Apus will make multiple close passes over the next century means that the risk of an impact could increase in the distant future. In 2068, the asteroid will come even closer, and it's possible that gravitational forces from Earth could shift its path. While scientists are confident that the asteroid will not strike Earth in 2068, they continue to monitor its orbit carefully. In 2010, a phenomenon known as the Yarkovsky effect was identified as a potential factor in altering Apus's orbit. The Yarkovsky effect occurs when an asteroid absorbs sunlight and then re-emits the energy as heat. This uneven heating causes the asteroid to experience a slight push in the direction opposite to its spin. Over time, this effect can cause an asteroid's orbit to shift, and for large objects like Apus, the Yarkovsky effect could be significant enough to change its trajectory. The potential impact of this effect on Apus's future trajectory raised new concerns about the possibility of a collision. Yet, after analyzing new data and conducting further observations, NASA reassured the public that the risk of an impact in 2068 was negligible. Even though the Yarkovsky effect is still a factor to consider, it is not expected to alter Apus's path enough to bring it on a collision course with Earth. As a result, the likelihood of a catastrophic impact in the near future is extremely low. That said, Apus's repeated close approaches offer a valuable opportunity for scientific research, and studying this asteroid is essential for understanding how other near-Earth objects might behave in the future. While the threat from Apus may seem far off, the ongoing study of this asteroid provides important insights into planetary defense. The close approaches of Apus give scientists a rare chance to observe the asteroid in great detail, and the data collected from these observations will help improve our understanding of how to defend against potential asteroid impacts. Research into asteroid composition, structure, and behavior is vital for developing effective strategies for preventing an impact. If a future asteroid were to pose a real threat, scientists could use this knowledge to develop techniques for deflecting the object and preventing a collision. One of the key areas of research is developing technologies to deflect an asteroid from its path. Currently, there are several potential methods for asteroid deflection, including nuclear explosions, kinetic impactors, and gravity tractors. A nuclear explosion could theoretically disrupt or alter the asteroid's trajectory, but this method would require precise planning and execution to avoid making the situation worse. Kinetic impactors, which are spacecraft that would collide with the asteroid at high speed to change its course, have been proposed as a more reliable method. Another potential technique is the gravity tractor, which would involve sending a spacecraft to fly near the asteroid and use its gravitational pull to slowly alter its path. These methods are still in the experimental stages, and we have yet to test them on an asteroid as large as Apus. However, ongoing missions to study near-Earth objects and research into planetary defense technologies are helping to prepare for the possibility of an asteroid threat. NASA's Planetary Defense Coordination Office is leading the charge in identifying and tracking near-Earth objects, and efforts are underway to develop better strategies for preventing an impact. In addition to asteroid deflection techniques, scientists are also working on improving our ability to detect and track near-Earth objects. The more we learn about these objects, the better we can predict their paths and assess the potential risk they pose to Earth. One of NASA's key initiatives in this area is the Near-Earth Object Surveyor mission, which is set to launch in 2028. This space telescope will be tasked with identifying and tracking near-Earth asteroids, including those that are too small or too faint to detect with current technology. By improving our ability to detect asteroids early, we can take proactive steps to prevent a future collision. In the meantime, NASA and other space agencies have been holding regular drills and exercises to prepare for a potential asteroid impact. In 2016, NASA conducted a simulated exercise in which participants were tasked with developing strategies for responding to a hypothetical asteroid threat. The results of this exercise highlighted several key issues, including the difficulty of coordinating a global response and the challenges of managing public communication in the event of an asteroid impact. Despite these challenges, the exercise helped to raise awareness of the asteroid threat and led to recommendations for improving international collaboration and preparedness. The lessons learned from these drills are crucial for preparing for the worst-case scenario. While we may not be able to prevent every asteroid impact, we can take steps to mitigate the damage and protect vulnerable populations. In the event of a real asteroid threat, timely and accurate information will be essential for coordinating a response and ensuring that people have the information they need to stay safe. The idea of a space rock impact has captured the public's imagination, and headlines warning of an asteroid collision have caused panic in recent years. One such headline, claiming that there was a 72% chance of an impact in 2038, was widely circulated. However, this figure was based on a theoretical simulation designed to help experts better plan for an asteroid crisis. While the risk of an impact in 2038 is extremely low, the simulation highlighted the importance of preparedness and the need for continued research into asteroid defense. In conclusion, while the threat of an asteroid impact like Apus may seem like something out of a disaster movie, it is a very real concern for scientists and space agencies around the world. Fortunately, the chances of an impact in the near future are extremely low, and efforts to track and study near-Earth objects are helping to improve our understanding of the risks. By continuing to develop planetary defense technologies, improve asteroid detection, and conduct crisis simulations, we can ensure that we are prepared for any future asteroid threat. While the risk may not be immediate, the lessons we learn today will help safeguard our planet for generations to come.